Welcome back, everyone, to another deep dive. We love to get into the nitty-gritty, and this time we're going quantum. That's right, quantum physics. And, this is all thanks to you, our listeners. You sent in some seriously cool research on something called the Hofstadter butterfly.
Yeah, it's a pretty wild concept. And
it's not just a concept anymore. Get this, scientists at Princeton University actually observed it.
It's amazing. Really, they managed to visualize this thing for the first time ever, and
it's not just some theoretical idea, it's a beautiful fractal pattern that actually exists. Right. So before we go full-blown quantum,
maybe we should
take a step back.
Start with the basics.
What is this butterfly?
Right, so the Hofstadter butterfly, in the simplest terms, it's this really complex self-repeating pattern, and it appears when you subject electrons to two things at the same time. You need a periodic potential, like you'd find in the structure of a crystal lattice.
Okay.
And then you also hit it with a strong magnetic field.
So it's like revealing a hidden world.
Yeah, like a hidden world of energy patterns.
I like that.
Yeah, for almost 50 years, it was just this theoretical concept, just a mathematical prediction. And now we can actually see this incredibly intricate fractal. And that means its structure repeats itself on different scales.
That's so cool. But how did they even see this? How did the Princeton researchers actually do it?
They used this really advanced technique called quantum microscopy, and this allowed them to measure the energy levels of electrons, but not in just any material. They used something called twisted bilayer graphene.
Okay, so I've heard of graphene, but what's so special about this twisted bilayer stuff?
It's all about these moiré patterns that form when you stack two layers of graphene and then you twist them. But you got to twist them at a very specific angle. And these patterns, they actually create like an artificial lattice structure. And that is the key to being able to observe the Hofstadter spectrum.
Wow. So they essentially built a custom-made environment to trap and study this elusive butterfly.
Yeah, that's a great way to put it.
That is so ingenious.
It is really cool.
Okay, now I know this is about way more than just proving a theory, right? This butterfly has some serious implications.
Yeah, you're absolutely right. The potential applications are huge. For example, let's talk about quantum computing.
Quantum computers, those machines that promise to revolutionize everything, but haven't they been struggling to become a reality?
Exactly.
Yeah.
One of the biggest challenges is the fragility of quantum bits, or qubits. Those are the building blocks of quantum computers. They're very susceptible to errors. But here's where the Hofstadter butterfly comes in.
Okay.
Because of the unique physics involved, and specifically something called the quantum Hall effect, it could help create far more stable qubits.
So hold on, can you explain the quantum Hall effect in simple terms?
Sure. So the quantum Hall effect in simple terms, it describes how the electrical resistance of a two-dimensional material changes. But it changes in a quantized manner under strong magnetic fields is a very specific condition, where electrons behave in a highly organized way. When you connect this to the Hofstadter butterfly, its unique energy levels, they're derived from these conditions and they could translate into qubits that are far less likely to decohere or lose their quantum state.
So
This would be a significant improvement, paving the way for more reliable and powerful quantum computers.
So we could finally see those mind-blowing applications everyone's been talking about, from personalized medicine to cracking complex codes.
Precisely. Problems that are practically impossible for even the most advanced computers today could become solvable.
Wow.
But quantum computing is just one area.
And this understanding of electron behavior in the Hofstadter butterfly also has incredible potential in the field of materials, doesn't it?
You're absolutely right. Think about this. The butterfly shows us that we can manipulate electron behavior in incredibly precise ways, and this could open up the possibility of creating materials with properties we can only dream of right now.
Can you give us some concrete examples? What kinds of materials are we talking about?
Well, imagine superconductors that work at room temperature without needing bulky cooling systems, or materials that are both incredibly strong and incredibly lightweight, completely revolutionizing fields like aerospace and construction.
Those examples sound straight out of a sci-fi movie.
I know, right?
So are we basically talking about manipulating matter at the atomic level to create entirely new things?
That's a great way to put it. We're on the verge of a materials revolution.
This is already mind-blowing, but there's even more, right?
Yep.
I read about potential applications in the world of electronics as well.
Absolutely. This discovery could lead to revolutionary advancements in nanoscale electronics. Think about even smaller, faster, and more energy-efficient devices.
Hold on, are we talking about smartphones that charge once a month or computers the size of a grain of rice?
Those are certainly possibilities.
Wow.
The Hofstadter butterfly's unique energy levels and conductivity properties could lead to the development of incredibly efficient transistors and other electronic components.
So we've got quantum computing, advanced materials, and revolutionary electronics. It's like this butterfly is causing a whirlwind of innovation.
It really is amazing.
And we haven't even touched on the broader implications for fundamental physics research.
Right.
This is a major leap forward in our understanding of the quantum world.
Yeah.
What are some of the big questions in physics that this discovery could help us answer?
One of the most fundamental mysteries is the nature of quantum entanglement. It's the idea that two particles can be linked, so they share the same fate, no matter how far apart they are. It seems to defy our understanding of space and time.
Okay, but how does the Hofstadter butterfly help us with that?
It provides a new lens to study quantum systems. This butterfly emerges from complex interactions between electrons, magnetic fields, and the underlying structure of matter. By studying its patterns, we can gain a deeper understanding of these interactions at the quantum level, which could shed light on the mechanisms behind entanglement.
So we're not just talking about better gadgets, we're talking about unlocking some of the deepest secrets of the universe.
Exactly. And we're just at the beginning. This discovery has opened up a whole new field of exploration. Who knows what other strange and beautiful patterns are waiting to be discovered in the quantum realm?
It's like we've stumbled upon a whole new continent of scientific discovery.
It really is.
But before we start mapping out this new quantum landscape, let's take a step back and consider the challenges ahead. Even with this breakthrough, we're still in the early stages of understanding the Hofstadter butterfly and its implications, right?
You're absolutely right. One of the biggest challenges is understanding the role of electron interactions in the system. Hofstadter's original theory didn't take these interactions into account, and we're now seeing that they play a crucial role in the emergence of the butterfly pattern. So we need more sophisticated models to fully exploit the potential of this discovery.
So it's like we found this amazing butterfly, but we're still trying to figure out exactly how it flies.
That's a good analogy.
But what about the experimental side of things? Aren't there also challenges in actually working with these quantum systems in a lab setting?
Absolutely. Observing the Hofstadter butterfly requires incredibly precise control over materials in experimental conditions. We need to continue developing new techniques and tools to probe these systems with even greater precision.
And I imagine it's a whole other challenge to translate these fundamental discoveries into practical applications. It's one thing to observe the butterfly in a lab, it's another to build a quantum computer based on its principles. What are your thoughts on that?
You've hit another crucial point. Bridging the gap between fundamental research and technological innovation is always a challenge. But that's part of what makes this field so exciting. We're pushing the boundaries of what's possible, both in our understanding of the universe and in our ability to manipulate it.
It's like standing at the foot of a mountain looking up at the summit. We know the climb will be difficult, but the view from the top promises to be breathtaking.
I like that.
But let's not forget why we're here. This deep dive started because you, our listener, brought us this research. What were some of the things that stood out to you in the materials you sent us?
Well, one thing that immediately caught my eye was the prominence of twisted bilayer graphene. This material seems to be at the forefront of a lot of the most exciting research in quantum physics these days.
It's like this wonder material that's suddenly unlocking all sorts of doors in the quantum world.
Exactly. And the fact that we can now use it to observe the Hofstadter butterfly suggests that it could hold even more surprises for us down the line.
That's a fascinating thought. It makes you wonder what other strange and wonderful phenomena are hiding within this material, just waiting to be discovered. But it wasn't all about the materials, right? What about the potential applications? Did anything in particular jump out at you there?
I have to say the possibilities for quantum computing were particularly exciting. The idea that we could use the Hofstadter butterfly to create more robust qubits has the potential to be a real game changer.
Quantum computers that could design life-saving drugs, simulate the birth of the universe, or even crack supposedly unbreakable codes. The potential really is mind-boggling.
Exactly. And the potential applications in material science were equally intriguing. The prospect of being able to design materials with properties that we can only dream of today is pretty incredible.
Imagine a world where we could create materials that are stronger than steel, lighter than air, and conduct electricity with perfect efficiency. The possibilities really do seem endless.
It really does feel like we're on the cusp of a technological revolution, and this butterfly is right there leading the charge.
But as with any revolution, there are bound to be some challenges along the way. What are some of the things we should keep in mind as we venture further into this quantum frontier?
You're right. We need to proceed thoughtfully. One thing to consider is the complexity of these systems. We need to be careful about making assumptions or oversimplifying things. The interactions between electrons and the material properties can be incredibly nuanced and Sicily. We're still learning about the full range of possibilities.
So even though we've made this amazing discovery, there's still a lot of ground to cover in terms of really understand how to harness its power.
Exactly. We need to continue pushing the boundaries of our knowledge and developing more sophisticated theoretical models and experimental techniques.
It's like we've taken the first step into a vast, uncharted territory, and there's still so much to explore and discover.
Absolutely. This is just the beginning of a very exciting journey.
It's incredible to think about all the potential breakthroughs that might be waiting for us. But before we get too carried away, maybe we should bring it back to the research you shared with us. Were there any specific findings or insights that particularly caught your attention?
Well, I was really struck by the sheer precision required in these experiments the researchers had to manipulate matter at the atomic level, controlling the twist angle between the graphene layers with incredible accuracy. It's a testament to the incredible advancements in nanotechnology and experimental techniques.
It's mind-blowing to think about manipulating individual atoms like that. A lot of times we think of quantum physics as this very abstract theoretical field. But this discovery really highlights the tangible nature of it, wouldn't you say?
Absolutely. This is a concrete manifestation of quantum phenomena. It's not just equations on a blackboard anymore. We're actually seeing these patterns emerge in the real world.
And it's not just about seeing it, is it? It's about understanding it and potentially harnessing it for practical applications. That's where things get really exciting. Speaking of applications, were there any particular areas that stood out to you in the research you sent?
Well, aside from the obvious implications for quantum computing and materials science, I was really intrigued by the potential impact on our understanding of fundamental physics. The Hofstadter butterfly offers a unique window into the quantum realm, and it could help us answer some of the biggest questions we have about the nature of reality.
Can you elaborate on that a bit? What kind of questions are we talking about?
Well, for example, one of the biggest mysteries in physics is the nature of dark matter and dark energy. These enigmatic entities make up the vast majority of the universe, yet we know very little about them. Some physicists believe that the Hofstadter butterfly and other exotic quantum phenomena could provide clues about the nature of these elusive substances.
That's fascinating. So this discovery could potentially have implications that extend far beyond the immediate applications in computing and materials.
Absolutely. The Hofstadter butterfly is like a key that unlocks a door to a whole new realm of scientific exploration. We're just beginning to scratch the surface of what we can learn from it.
It's like we've been given a new set of lenses to view the universe with, but even with these new lenses, we're still facing a lot of unknowns, aren't we?
Definitely. The research you sent highlighted some of the challenges that lie ahead, for instance, scaling up the production of twisted bilayer graphene and other materials. With the necessary precision is a significant hurdle. We need to find ways to produce these materials reliably and on a larger scale if we want to fully realize their potential.
That makes sense. It's one thing to create these systems in a highly controlled lab environment, but quite another to manufacture them on a scale that's commercially viable.
Exactly. And then there's the issue of integrating these new materials into existing technologies. It's not simply a matter of swapping out old components for new ones. We need to develop entirely new design paradigms and engineering approaches to fully exploit the unique properties of these quantum materials.
So it's not just a materials challenge, it's also an engineering and design challenge.
Precisely. And it's going to require collaboration across multiple disciplines. Physicists, materials scientists, engineers, and computer scientists will all need to work together to bring these quantum technologies to fruition.
It sounds like it's going to be a truly interdisciplinary effort, which is exciting in itself. One thing that really struck me about the research you shared was the sheer audacity of it all. These scientists set out to visualize a pattern that had only ever existed in theory, and they succeeded.
It really is a testament to the power of human ingenuity and our insatiable curiosity. And it makes you wonder what other seemingly impossible feats we might accomplish in the future.
Speaking of the future, what are some of the areas where you think this research could have the biggest impact down the line?
Well, in the realm of quantum computing, the potential applications are vast. Imagine being able to simulate complex molecular interactions to design new drugs and therapies. or develop entirely new materials with properties we can't even imagine yet.
Those are some pretty incredible possibilities. It sounds like we're talking about revolutionizing entire industries from healthcare to energy production.
Exactly. And let's not forget about the potential advancements in artificial intelligence. Quantum computers could process information in ways that are fundamentally different from classical computers, leading to breakthroughs in machine learning and AI that could transform our lives in ways we can't even begin to comprehend.
It's almost overwhelming to think about the potential scale of these advancements. As we delve deeper into this topic, I keep coming back to the visual metaphor of the butterfly.
Okay.
Well, we've been talking about all these potential breakthroughs and revolutions, but a butterfly is also a symbol of delicate beauty and transformation. It makes me wonder if this discovery is not just about technological advancements, but also about a shift in our understanding of the universe and our place within it.
I love that perspective.
Yeah.
It's a beautiful way to think about it. Perhaps this discovery is a sign that we're entering a new era of scientific understanding, one where the seemingly impossible becomes possible and the boundaries between different fields of knowledge begin to blur.
It's a reminder that science is not just about cold, hard facts and data. It's also about wonder, imagination, and the constant pursuit of knowledge and understanding.
Absolutely. And just as a butterfly emerges from its chrysalis transformed and ready to take flight, perhaps we as a species are on the verge of a similar transformation, ready to soar to new heights of knowledge and innovation.
That's a powerful image. And as much as we've covered in this deep dive, I feel like we've only just scratched the surface of this fascinating topic.
I completely agree. The research you sent us has opened up so many new avenues for exploration and discovery.
And that's what makes this so exciting. It's not just about the answers we found, but about the new questions that arise, the new mysteries that we're now equipped to explore.
Exactly. The journey of scientific discovery is never ending. And the Hofstadter butterfly is a beautiful reminder of that.
It really is a journey, isn't it? And this time you, our listener, are the one who set us on this path. What aspects of this deep dive have resonated most with you?
What strikes me most is the elegance of it all. Here, we have this seemingly simple pattern, a butterfly, and yet it holds within it the potential to unlock some of the most profound secrets of the universe.
It's a beautiful reminder that complexity can arise from simple rules and that even the most intricate phenomena can sometimes be traced back to fundamental patterns.
Absolutely, and that's what makes science so captivating. It's the search for those underlying patterns, those unifying principles that govern the universe.
And in this case, that search has led us to the mesmerizing world of the Hofstadter butterfly. We've talked about its implications for quantum computing materials, science, even our understanding of the universe itself.
But perhaps the most significant implication is the one we haven't fully explored yet, the one that lies in the realm of human potential.
What do you mean by that?
The discovery of the Hofstadter butterfly is a testament to the power of the human mind. Our ability to conceive of these abstract concepts, to develop the tools to observe them, and to unravel their implications is truly awe-inspiring.
It's a reminder that we are capable of extraordinary things when we set our minds to it.
Precisely, and I believe this discovery will inspire a new generation of scientists and engineers to push the boundaries of knowledge even further.
So as we wrap up this deep dive, maybe the biggest takeaway isn't just about the science itself. It's about the human spirit of inquiry and innovation that drives us to explore the unknown.
I couldn't agree more. The Hofstadter butterfly is a symbol of that spirit, a reminder that the pursuit of knowledge is a journey worth taking no matter where it leads.
And on that note, we want to thank you, our listener, for sharing this fascinating research with us. It's been an incredible journey exploring the intricacies of the Hofstadter butterfly.
We hope you've enjoyed this deep dive into the quantum realm as much as we have.
And as always, we encourage you to keep exploring, keep asking questions, and keep pushing the boundaries of your own understanding. Until next time, keep diving deep.